Hello, we are back. Sorry about the abrupt ending on the last video. I had intentions of doing problem number 6, and after I finished it, I realized I missed the minus sign, so my answer was not correct. So we'll begin with solve for x here in number 6, in which case we're going to square both sides. Okay, and a square and a square root cancel each other out. Now I'm going to multiply both sides by 5. It's 250 and 40 is 290. I'm going to move my 15x. I'm going to move my 2x over here. And this is the mistake I made last time. I need to add 290, not subtract 290. So we get 290 over 13. When I plug 290 over 13 in here, I get a positive, so we're good. Plug it in here, I also get a positive, so we're good. The issue I ran into last time, I wrote negative here, which would have given us an extraneous solution because we can't have a negative solution inside of a square root. Let me rephrase it. You can't have a negative value inside of a square root. Alright, on to number 7 here. Again, I think I'm going to square both sides, so x minus 1. This, be careful, when we square this, you get x squared minus 14x plus 49, combined like terms set equal to 0. X squared minus 15x plus 50. And I believe that's going to factor pretty darn nice there, isn't it? X minus 10, x minus 5. So our two solutions so far are 5 and 10. Plug them both in, we're good. Positive values in there, we're good. 5 and 10. All right, down here, you know, each his own, whatever you want to do here. I think I'm going to move this radical, combine that with a number. So actually, let me do this. Square root of x, subtract 2 from both sides. I'm going to add square root of x minus 4 to both sides. And now I'm going to square both sides. So this one becomes just x minus 4. This one's a little hairier. We get x minus 4 root x plus 4. Okay, so I still have a radical to deal with here, but I'm going to leave that, isolate that rather. I'm going to subtract x from both sides. Those guys are gone. Let me just cross them out. I'm going to add 4 over here, so I get an 8. So 8 equals 4 root x, which means root x equals 2, which means x equals 4. Bada bing, bada boom. Plug it in for a quick check. Square root of 4 is 2. 4 minus 4 is 0, so 2 minus 0, 2. Ring-a-ding-ding, we got that one. All right, part 7 here. Simplifying. So numerator factors, difference of squares, m plus 7, m minus 7. 8m I'm going to leave alone. 3m I'm leaving alone. M plus 7 here. Let's go back to the blue. M plus 7 is gone. M is gone. So I end up with 3 times m minus 7 over 8. Here I can factor an s out. So that's an s plus 5. Denominator, I can factor that into s minus 4, s plus 3. I'm going to change this to multiplication, which means I'm flipping my fraction. That's an s minus 4, and this is an s plus 5. S's and 5s, I do not recommend using them in the same problem. S plus 5, S plus 5, S minus 4, S minus 4. So we're left with S over S plus 3. Add or subtract and simplify as much as possible. In order to add fractions, we must have a common denominator. So I'm going to multiply this guy by y over y, so it becomes 3y over xy. And this one by x over x, so it becomes 7x over xy. And we combine them to make 3y plus 7x over xy. I'm excited to see what the next page has. Oh, nice. More. All right, so here we have x minus 6 and x plus 1. X plus 5 and x minus 2. You know what? I'm kind of stuck on a routine here. There's no need for me to do that at all because they already have common denominators. I'm just going to add So we have x squared minus, right, minus 5x and plus 4x make a minus x, and here I end up with a plus 6. X plus 5, x minus 2 is my denominator. It appears my numerator is going to factor 3 and 2. No, it will not, because that's a plus sign there. So x plus 3 and x plus 2 gives us a middle term of 5. Plus 6 and 1 doesn't work. Minus 3 minus 2 doesn't work, so we're done. X squared minus x plus 6, that looks like it wants to factor, but it doesn't. He's tricking you. Did I jump too far there? I did. Now we're jumping all around here. All right. This one, on the other hand, we need a factor just so we can find what our common denominator is. X minus 6, x plus 1. And then down here we have x plus 9, x plus 1. Minus 1 over x plus 9. So rather than create a common denominator by multiplying, I'm actually going to cancel out, and now I have a common denominator. X minus 6 minus 1 is x minus 7. And my common denominator is x plus 9. Here, what we got? 7. We can take out a 3x and get an x minus 2. Plus, I got an x squared. And that's going to be what? An x minus 2 times x minus 2. X minus 2 squared, in other words. So this one needs an x minus 2 on the bottom. So if I put one on the bottom, I got to put one on the top. And this one needs a 3x on the bottom. And likewise, I need to put that up top. So we've got our common denominator established. So our numerator, the left numerator, 7x minus 14. The right numerator is 3x cubed. And the denominator is 3x times x minus 2 squared. And I'm just going to write that in more conventional highest degree polynomial first. And that'll be my final answer. We know the numerator cannot be factored because of how we created the numerator. Right? The numerator was created by 7 times x minus 2 and this by 3x squared. They have nothing in common. So we cannot factor that any further. Alright, let's solve this one and see what we got on the next page before we move on. So if I'm solving this, I'm actually going to add to the other side. 2 over z minus 2. Boy, 2's and z's, man, just like 5's and s's. I'm going to make my 2 like that now. Equals 3 over z plus 4. So in this case, I'm going to multiply by a common denominator, which is z plus 4, z minus 2. Most of you probably refer to that as cross multiplication. In any case, common denominator, like I said, is z plus 4 and z minus 2. Z plus 4 and z minus 2, right? As long as I do the same thing to both sides. Now the reason cross multiplication works is because these z minus 2's cross out here. Z minus 4's cross out. So it looks like I'm multiplying this 3 by only z minus 2, right? So that becomes 3z minus 6, and this becomes 2z plus 8. Combine like terms, subtract, so I get z equals 14. Alright, next page. I think we're making good progress here. Common denominator. This guy right here factors into x plus 4 and x minus 1. Alright, so I'm going to multiply the entire fraction by the common denominator, x plus 4 times x minus 1. Such that when I distribute to this first term, the x minus 1's cross out. So I have x times x plus 4. When I distribute to this second term, the x plus 4's cross out. So I have 4 times x minus 1. And when I distribute to this term, the entire denominator crosses out with that. So I have just my 16x. And now this is an easy problem. X squared plus 4x, 4x minus 4, and 16x. Looks like we have an 8x there. So x squared, I'm going to subtract 16x, x squared minus 8x minus 4 equals 0. Does not appear to be factorable, so quadratic formula. X equals opposite of b plus or minus a square root b squared minus 4 times a times c all over 2a. So 8 plus or minus the square root of 64 plus 16 over 2. So 8 plus or minus the square root of 80 over 2. 80 can break down to 16 and 5. 16 and 5, square root of 16 is 4, so 4 root 5 over 2, and 8 and 4 are both even, so they can be divided by 2, and we end up with 4 plus 2, 4 plus or minus 2 root 5. We'll call that a video, and we'll wrap it up on the next one now, beginning with number 4, simplifying the complex fractions.